All right, we're going to cover section 3.3, graphing intercepts. So the x-intercept and y-intercept, you can see the definitions. So make sure you write those down. But remember, we can have intercepts. It doesn't just have to be a line. So let me just make up some random function that crosses both axes several times. And all of these points where it crosses the x-axis should make sense that these points in pink are all x-intercepts because it's where the function intercepts the x-axis. And then likewise, we only have one y-intercept for this problem because this is where it intercepts the y-axis. So that's what a y-intercept looks like. Important to know, this is essentially what we're going to do to find both of those intercepts. So the y-intercept, the x value is always 0. So all of the values on the y-axis, all of the x values on the y-axis are 0. And counter to that, all of the values on the x-axis for the y-coordinates are 0. So that's why we set each of those equal to 0 to solve for the other. And you'll notice every line typically has 2. I shouldn't say every line. Some lines just have a single intercept if it goes through the origin. But we need 2 points to graph a line. So that means we can make our 2 intercepts the points we're going to use to graph these lines. So let's see what we're talking about here. So let's first find the x-intercept, where this graph crosses the x-axis. So to find the x-intercept, we're going to set y equal to 0. I'm going to go and set my t-chart or my table over here to the right. To find the x-intercept, we're going to set y equal to 0. So I'm going to put 0 in for the y column, and then I'm going to do this math. So that's 2x minus 5 times 0 equals 40. The 5 times 0 goes away because that's just 0. And then divide both sides by 2. And just like that, that's a 40, not a 4. It's a big difference. So our x-intercept is the point 20, 0. We'll talk about in a second how to actually graph that. And then we're going to find the y-intercept in basically the exact opposite way. We're going to set x equal to 0. Doesn't matter which one you find first. And just like the last one, the term with the 0 cancels out. So we've got negative 5y equals 40. Divide both sides by negative 5, and we get negative 8. We actually only need 2 points to graph a line. So we're going to graph those 2 points, 20, 0, and 0, negative 8. Point 20, 0 doesn't fit on this graph very well. So what I'm going to do is I'm going to count by 2's on the x-axis. So we talked a little bit about this in the first video. There's 10 tick marks. So if we divide that biggest number by 10, we get 2, and that's how we can decide what to count by. So the point 20, 0 then would be way over here. And the point 0, negative 8, we're still just counting by 1s on the y-axis. Is going to be right here. Connect your dots, and there's your graph. So that's literally all there is to it, graphing intercepts. You only need 2 points. You can substitute 0 for y and 0 for x to get those. All right, let's do one more. So this one's in slope intercept, typically making just a regular t-chart where we substitute numbers for x, would be the easiest way to graph this. Since this problem is already solved for y, picking convenient values for x would be a quick way to do this. But it says graph using intercepts. So to find the x-intercept, you would set y equal to 0. Got to do a little bit of math here, and we are going to end up with a fraction. So again, you can see another reason why really a better way to graph this one would be just to substitute values for the x variable. So we get 4/3. Let's write that as a decimal, so it's a little bit easier to graph. So that's 1.3 for x and 0 for y. So it's going to be somewhere right about there on our x-axis. And then we're going to do the same thing to find the y-intercept, or really the reverse. We're going to substitute 0 for x and then solve this equation for y. So I get -4 for my y value and 0 for my x. It's never a bad idea to check by using a third point just to make sure that our line is correct. So if I can do that real quickly, substitute 1 for x back into the original problem. And this will tell you whether or not you did the first 2 points correctly. 3 times 1 minus 4 is -1. This obviously isn't an intercept, but it falls right in between my 2 intercepts on that diagonal line. So that tells me my intercepts are accurate. So sometimes just picking that third point is a good idea to check to see if they all 3 will fall in a line. All right, pause the video and try the your turn. So first off, those are the points that I got. 0, -30 for the y-intercept, 20, 0 for the x-intercept. So I decided to count by 2 on the x-axis because the largest x value is 20. And 20 divided by 10 tick marks, that's how many tick marks we have on the x-axis. 20 divided by 10 is 2. And the largest y value is -30, so -30 divided by 10 is 3. So that's why I counted by 3s. Then finally, I did a checkpoint. This is optional. But there's my checkpoint. There's the math. And you can see it does fall in line with those other 2 pink dots. The last thing I want to briefly talk about, this is actually in the next section, but we're going to go and hit it real quick, is graphing horizontal lines and graphing vertical lines. So vertical lines are always of this form, x equals a. And the x-intercept is whatever the a value is in that problem. Horizontal lines are always of this form, y equals b. B can be any number, and the y-intercept is at whatever number the equation is talking about. So let's look at an example real quickly. When it says graph y equals 3, so I could make a t-chart for this equation, but the thing we notice is there is no x variable in this problem. One thing we definitely do know, though, is y is 3. And in fact, since there is no x variable, we really can pick anything for x. No matter what x is, y is always equal to 3. So we're going to graph the point 0, 3. That's our y-intercept. And then graph another point where the y-coordinate is 3. Which essentially is all of these points I'm plotting right now. So y equals 3 is a horizontal line that has a y-intercept at 0, 3. And x equals -4 is just going to be the reverse of that when we make a t-chart. This time, what do you think you're going to put in that t-chart for x equals -4? There's not a lot of options. We're going to put -4 in for x every single time. What are we going to put in for y? doesn't matter because there is no y variable in this problem. So you literally can pick anything you want for y, as long as you graph where x equals -4. So x is equal to -4 there, x is equal to -4 there. The y coordinate is changing, but the x coordinate is always staying at -4. So x equals a number is a vertical line, and this one has an x-intercept at -4, 0.